Hello, welcome back to another Science 10 video. For this video, we're going to take a look at some ways we can represent and read data regarding climate. Okay, our focus, of course, as I've been teasing, is the climatograph. But let's introduce a few methods we're probably already familiar with. Okay, so the ways to interpret data. First, we have the circle graphs or pie charts. You may probably know it as. It's very useful to look at data as part of a whole. Okay, so perhaps, how much time you get done in a day. Okay, average day. Is your day like that? Is your day like that? Okay, try your own, but writing notes with pencil with pen. Okay, just take a guess. Anyhow, but the second one you're probably familiar with is the bar charts. Okay, the bar charts or probably histograms. It's very good. A manipulated variable is separated in different categories. If you remember from math, it would be from different intervals, right? Different intervals. Disjoint or continuous. Okay, disjoint or continuous, or discrete or continuous data would be probably more useful for a bar chart because you can use a variation of bar charts called histogram for continuous data. So here's an example of a bar chart. Maybe the CO2 emissions, different categories, right? What sector, industrial sector, produces more CO2? Okay, this would be a great way to use bar chart to represent. Hopefully, I do not need to go over how to read a bar chart, but this is another way to use it. Okay, you can try this out. Another one, of course, is a line graph, as you see here. Global temperature trends. It's very good, once again, to see how the manipulated and responding variable change over time as a function, right? As comparison over a lot, especially over time like this one. Okay, global temperature change. Okay, it's line chart that you can see. Individual year, between years there is a lot of variation. It goes up and down and up and down, but the general trend, right, is trending, for instance, trending upwards. Okay, so it's line chart is great for that. Okay, line chart is great for that. But combining histograms or bar charts, okay, bar graphs, okay, which is good at looking at a different category, different sections, what the values is. This is very good to look at perhaps precipitation, right? Every month, how much water is falling, right? It's very good to look at something like precipitation, right? Every month, how much we got, and then to calculate total, we just need to add the columns up. Okay, and add the columns up. Okay, something like precipitation is somewhat useful. And let's look at trend over time. Great example here. Temperature is great, something to look at in terms of chart, because we don't really care about the total temperature. We care about the average, right? We care about the average. We want to see the trend of the temperature, not the actual amount of temperature. We don't add temperature up, right? We don't just add, what's total temperature of the year? That's not something we think about. Okay, that would be something for bar chart. But temperature, we don't add temperatures. So can we mix them together? Okay, and that gives us the climatographs. Okay, climatographs, which we'll focus on, climatographs consist of both the bar and the line graph. Okay, the bar chart shows precipitation, as I mentioned, precipitation because we want to know the amount. So total, we add the bars up. That's why we use the bar chart for it. We add the bars up. We're not looking at the average, we're looking at the trend. We want to know how much it is. Okay, so like I say that this, we want to know, I don't have to say want to know part. It give us how much it is. Okay, give us a quantity. Okay, it looks like a quantity of precipitation. Okay, and that's once again that is what we do, right? That's what we focus on. It's discrete data. I want to look at the quantity, the raw quantity, how much precipitation it is. Line, we want to look for trend, right? Temperature, we still know the quantity, of course, but more important, we're looking for trend. And we look for, the keyword is here, we're looking for, let's do it here, we're looking for average. I should say yearly total, annual total, we add the bars up. We look for annual. We don't look for total here. We look for annual average because we're looking for the trend in temperature. So we just find it's on a graph. It's just around the middle, right? It's very easy to find. Much harder to find total using a line chart because it waves a lot. Okay, it waves a lot. Much easier using a bar chart. Okay, but very easier to spot the average, right? So here is an example, or two examples. Edmonton, Alberta, for instance. I'm going to go over this one first. Remember, line is temperature. So during January and December, it's very cold. Minus 20. Temperature is below minus 10 at least. This is a fairly warm winter, actually. Consider, but it's average temperature of the month. So maybe there's minus 40 and a plus 10, sort of balance it out. Regardless, okay, cold winters, warm summers, average temperature during the months of, this is second J, so July. This is July. Okay, average temperature of July is 15, over 15. Okay, you have some hot days, of course, some cold days. The average of the month is that. So the average temperature, okay, is just the middle. The average temperature of the year. So average temperature, temp of the year, okay, would be somewhere around the middle. Think looks like it's just a little bit above 0. So 5, not quite 5. We're eyeballing it. If you want to be accurate, you should really take the max and min and figure that out. But I'm just going to eyeball this. So it looks like it's just above 0. So 1 or 2 degrees, about 0 degrees to maybe 2 degrees. It's average temperature. Let's look at total precipitation. Okay, oops, spoilers. Total. Oh, let's change color for that one. Let's use blue because the color was blue. So total precipitation. Precip. Okay, total precip. Well, how do we do that? Well, of course, one way is to figure out how tall each bar is, then we add them up. Okay, that's one way. So you can add number 1, of course, you can add the bars up. If you know the values, it would be very easy. Sometimes when we do data, we do, but in this case, we do not. So maybe we want to find a different way. Second is we can still use the average. Average fairly easy to spot. The average looks like it's around 40 centimeters monthly. We figure out the average, monthly average now. The month average. For this case, it's about 40. The unit is actually millimeters. Okay, not centimeters. Okay, you probably see it on the side here. It's actually millimeters. This is degrees Celsius. This is millimeters. If every month the average is 40, right? That's what the average is because it gives a raw amount, not a trend. Then how to calculate total? Well, total is just multiplied by 12. So multiplied by 12. So that is about 40 times 12, which is about I'm having a hard time doing this. 480 millimeters. Okay, 480 millimeters. And of course, if you look at the convert that to centimeters, if you look at our notes, which is about 48 centimeters. Okay, that's not too much water. But if you look at the our chart here, you'll notice, hey, 48 centimeters. Okay, 48 centimeters. That's right between 25 to 57 centimeters. Right. So the precipitation is around that. Temperature average is about it's pretty low, 0 to 2 degrees. Maybe give or take a little bit higher. So this is actually a typical. Grassland it says, and the notes probably says 4 to 18, but 2 is pretty close. The point is, this is a very typical grassland. Okay, so average temperature, total precipitation, it's 48. This is grassland, right? Grassland. Very typical grassland temperature. A little bit colder, actually, a little cooler in this particular region. Once again, differs by region. Okay, differs by region. Can you see what you would get for the Vancouver International Airport? So Vancouver, what do you think it is? You might notice the precipitation drops in the summer and rises in the winter. Why do you think that happens? Okay, think about that a little bit. Okay, but regardless, temperature is very similar to Edmonton, right? But a little bit warmer, right? A little bit warmer. It doesn't go into negative too much. Okay, a little bit warmer. And then look at the precipitation, quite a bit, right? Quite a bit. I need to check, but I believe it's not quite rainforest, but because temperature it does vary quite a bit. But I believe it is actually the mixed woodlands. Okay, mixed woodlands. So, okay, so yeah, so two different Climatograph. Okay, give it a try. Give it a try. Let's do some few more examples. Okay, so there is another example in Alberta. Okay, it is grassland, so you know that already. Let's take a look at the temperature and the precipitation. I recommend you try it out yourselves. Okay, try it out yourself. Pause this video. Okay, don't draw it on the computer screen though. Just eyeball it a little bit. See if the temperature average and the total precipitation are the same, are similar to grasslands. Hopefully, you actually took the pause of the video and try it out. Let's take a look. We'll do temperature on the side on a temperature. So temperature, okay, right around the middle here. It's average temperature is probably around here. So average temperature average is about 5 degrees Celsius. You can just eyeball it. And as for the precipitation, now you could once again add the bars up and get approximation of each bar for each month and add them up to get a more accurate one. But you can use second method, take the average and multiply it by 12. The average looks like it's about 25 might be a little high actually. Well, 25 is a good number though. Average, 25. 30 is a good number. So right here, right, this looks about the average precipitation. There's equal amount above it and about equal amount below. Okay, actually, I think maybe that's a little bit too high. Maybe more like 20, actually. The average is more like 20. Now, actually, I drew the line. The average temperature is more about, there we go. This looks more like it. So it's about equal amount of water above and equal amount below. Okay, not amount of water, equal amount of data points above and equal amount below. Okay, now this is too low. Regardless, it's somewhere between, let's pick 25. How about that? 30 is too few. 25, right there. Okay, ooh, I'll pick them right here again. 25. Okay, remember, you're just doing the estimate. This looks better. Okay, this is about equal amount above and equal amount below. 25, so monthly average is about 25 millimeters. Multiply 25 by 12, so year total is 25, of course, millimeters times 12 month times 12 month. And if I do that correctly, that's about 300. Did I do that correctly? Oh, you can check my math, but I think it's 300. Okay. 4 is, yeah, 300 millimeters, which is, I should use approximate sign because everything's approximate here, which is approximately 30 centimeters, of course. Hey, that falls into our grassland region, right? Our grassland region, remember our grassland region is, Our grassland region is somewhere around 4 degrees average temperature to 18 degrees, at least for our definition. And precipitation is somewhere around 25 centimeters to 57 centimeters. There we go. This falls in our range, right? Falls in our range. Okay, so this is typical grassland one. Okay, grassland one. Okay, let's take a look at another question. You might a little bit thinking for you. Okay, here is a tundra. It's in alert Nunavut. What do you think the climatograph for this one will look like with the chart? Doesn't have to be accurate. You don't have any actual data. Okay, of course. But just take a guess. What do you think the climatograph for this one will look like? Take a sketch. Okay, take a sketch. Okay, you can still expect summer to be relatively warmer and winter to be a little bit colder. But the one probably more noticeable is the precipitation. Give it a try. Pause the video. Give it a try. All right, you hopefully actually pause the video a little bit and actually give it a swirl and see. This one is going to be probably a little bit different from yours. Once again, they probably use data from some observations. So that's not a big deal. If yours is a little bit different, just see if you get the same trend. This is what it is, okay? Even though it might look like a big difference, okay, might look like a big difference, but you notice the temperature is very cold. The maximum temperature is only 5 degrees, okay, 5 degrees. And the minimum temperature, the coldest, okay, can go from minus 35, okay? It's pretty low temperature. The average temperature looks around minus 15 or so. That's forced in our tundra region. Our monthly average looks no more than 10 centimeters, right? No more than 10. So there's some, you have like specifically in July you have 20 some centimeters, while in the minimum we have millimeters, can say centimeters, 20 some millimeters, and in the winter months and February you have a little bit less. You only have like 6 millimeters, 5 millimeters. Okay, but if you add them up, it looks like we can take 10 as an average, 120 millimeters or 12 centimeters of water. Okay, every year. That's not very much. Okay, it's not very much. It's very little amount of water compared to, wow, the grassland, okay, even, which is already not very much. Okay, so this is typical tundra. Temperature cold, okay, still varies, but very cold. Temperature cold, very little precipitation. Okay, very little precipitation. All right, another challenge for you. What do you think this is a climatograph of? Okay, climatograph of. Think about it. Look at the line part, okay, line part, the temperature, and look at the precipitation. Look at the precipitation down below. Okay. Think about the average precipitation. What do you think it is? Once again, of course, pause the video and think about it a little bit. All right, welcome back. Let's take a look. Temperature goes from minus 15, it's really not minus 15, 15 degrees, 35 degrees. Average about 25 or so degrees, fairly warm, so we probably expect it in a warmer area. Could be rainforest. Okay, could be rainforest. It can even be I'm trying to say the word, mixed woodland, the deciduous forest. Okay, mixed woodlands even. But what really gives it away, okay, it's not just temperature, right? Temperature doesn't only give us half the picture, but also precipitation. The precipitation is really low. Okay, really low. The highest one is just above 10 millimeters. Okay, the average is probably around 5 millimeters times 12. That's 60 millimeters. That's 0 points. It's nothing. Okay, to put it simply, it's nothing. There's almost no precipitation all year long. So what is a place that's really warm but have no water? That's right. It's a desert. Okay, it's actually fairly mild temperature-wise for a desert, but it's typical, but it's desert, right? Little precipitation, high temperature. All right, let's go a quick back. So this is how you analyze and read a climatograph. Okay, we'll not be going too much how to collect data and draw one in this level, but you should able to predict the climatograph like a sketch, or you should able to recognize what would be an appropriate climatograph. Oh, it did not work. What would be appropriate biome a climatograph might describe? Okay, might describe. So this is it. Thank you for listening. This wraps up the conceptual part of this unit. Uh, the build-up part, which is first looking at what our biosphere is made up of. Then we look at energy exchange from the sun and how energy is generated through the hydrosphere and atmosphere through things like convection, and of course how the specific heat capacity, heat of fusion, heat of vaporization, how does those impact the energy flow as well on a local level. And then we put them together sort of, and then looked at different biomes that exist on this planet, not very detailed, but the 6 big general types we want to consider. Finally, I give you a tool we would normally use to represent different type of climates and biomes, which is called the climatograph. The next lesson will be taking a brief look at climate change. Okay, the study of climate change and what it is and what it's all about. It is a complex topic, so we will not be going over the details of all about climate change, but just giving you some familiarities about climate change and what are some of its impact. And with that, thank you for watching. I hope to see you next lesson, and have a good day.